Hello friends, today we are starting example number 9 from exercise 6.1. So observe the given condition in the example. We have to show that these two lines intersect each other. Equation of two lines are given to us and we have to show that these two lines intersect. We know that if two lines intersect each other, then how many point of intersections are there? Only one point of intersection is there, and question is to find out coordinate of the point of intersection also. Means in the first part we will try to show that these two lines intersect each other, and in the second part we will try to find out coordinate of point of intersection. So first consider equation of first line. So equation of first line is, what is the equation of first line? X plus 1 upon minus 10 is equals to y plus 3 upon minus 1 is equals to z minus 4 upon 1 is equal to, say, lambda. Okay, so therefore coordinate, now we are finding coordinate of any point on the line. So coordinate of point on the line first R. So let us try to find out coordinate of any point on the line. So means first we are trying to find out x coordinate. To find out the value of x coordinate, suppose that these two values are what? Equal. Simplifying it, we will try to find out value of x. Minus 10 on this side will get multiply, means minus 10 lambda, and plus 1 on this side will become minus 1, means minus 1 minus 10 lambda will be the value of what? X, means x coordinate of any point. What is x, y, z? Any point on that line. So now we are trying to find out value of y. Y means y coordinate of any point. Minus 1 into lambda is minus lambda, and plus 3 on this side will become minus 3. So minus 3 minus lambda will be the y coordinate. In the same way, z coordinate will be equals to, now 1 into lambda is lambda, and minus 4 on this side will become plus 4, means 4 plus lambda. So in this way we have got coordinate of any point on the line first. Let us denote it, say, by equation number first. Now we are considering equation of second line. So equation of second line is, so what is the equation of second line here? X plus 10 upon minus 1 is equals to y plus 1 upon minus 3 is equals to z minus 1 upon 4. Let us denote this equation or this ratio, say, by mu. Okay. So now we are finding coordinate using same method. Here we have got coordinate of any point on the line first. Now we are finding coordinate of any point on the line second. So therefore coordinate of any point on line second R. So let us try to find out x coordinate. Minus 1 into mu is minus mu, and plus 10 on this side will become minus 10, means minus 10 minus mu will be the x coordinate. Now try to find out y coordinate. Minus 3 mu plus 1 on this side will become minus 1, means minus 1 minus 3 mu will be the y coordinate. Lastly, find out z coordinate. 4 into mu is 4 mu, and minus 1 on this side will become plus 1, means 1 plus 4 mu will be the value of z coordinate. Let us denote it by equation number 2. Now coordinate of a point on line first is also known, and coordinate of any point on the line second is also known to us. What will happen if these two lines intersect each other? If these two lines intersect each other, means the point of intersection lie on the line first also and lie on the line second also, means it is the common point of both the line. Means here we can say that if it lie on the first line, means its xyz, whatever maybe its xyz coordinate are the same if that point lie on the second line also, because its position is fixed. Means if these two lines intersect each other, at that time we can say that x coordinate of both the point are equal, y coordinates are also equal, and the z coordinates are also what? Equal. So here we are supposing that if the line intersect, if the line first and second intersect, let us see what we will get if these two lines intersect. If these two lines intersect, then x coordinates are equal, means what we will get? Minus 1 minus 10 lambda is equals to minus 10 minus mu. So by comparing x coordinate, we will get this equation. Let us compare y coordinate. What we will get? Minus 3 minus lambda. Minus 3 minus lambda will be equals to minus 1 minus 3 mu. And comparing z coordinate, we will get 4 plus lambda is equals to 1 plus 4 mu. Let us simplify these three equation and try to convert it in terms of linear equation in two variable. So here minus 10 lambda on this side will become plus 10 lambda. So 10 lambda minus mu, collect the constant term on this side. Minus 10 on this side will become plus 10. 10 minus 1 will be equals to 9. In this way we have got another equation. Let us denote it by equation number 3. Now simplify it. Minus lambda on this side will become plus lambda minus 3 mu is equals to minus 1 on this side will become plus 1. So on this side we will get minus 2. Let us denote it by equation number 4, and later on we are trying to find out last equation from this expression. Plus 4 mu on this side will become minus 4 mu is equals to plus 4 on this side will become minus 4. 4 minus 1 will be equals to minus 4 plus 1 is equal to minus 3. Let us denote it by equation number 5. In this way, now here we have got three equation 3rd, 4th and 5th. If you observe these three equations, all the equations are in terms of what? Lambda and mu. Means we can say that these are three linear equations in terms of two variable. Which two variable? Lambda and mu. Now we will have we will have a choice here. Solve any two equation. Either solve first and second, or first and last, or solve last two equations, and try to find out value of lambda and what? Mu. So here if you observe this equation, if you are taking subtraction of these two equations, here coefficients of lambda are what? Equal. If you are taking subtraction of these two equations, lambda will get cancelled and we will get the value of mu. So for simplicity, we are solving equation 4 and 5. So solving equation 4 and 5. Let us see what we will get here. So it is considerable that as you are the student of class 12, you are orally also you are able to solve the linear equation. So here if you are taking subtraction, lambda minus lambda will get what? Cancel. Minus 3 mu minus minus means plus 4 mu. Minus 3 mu plus 4 mu is equals to mu. And on this side minus 2 minus minus 3 means plus 3. Minus 2 plus 3 will be equals to 1. Means what we have got here, mu is equals to 1 and lambda is equal to. Let us try to find out value of lambda. To find out value of lambda, substitute this value of mu either in the equation number 4 or equation number 5, because we are solving these two equations. So replace lambda by 1. So plus 1 into minus 3 is minus 3. Minus 3 on this side will become plus 3. 3 minus 2 is equal to 1. Means lambda is also equals to 1. Now these two values we have got by solving which two equation? 4 and 5. Means definitely these two values satisfies these two equation. These two equation we have got by comparing what? Y coordinate and Z coordinate. These two equation we have got by comparing Y coordinate and what? Z coordinate. Now here two possibilities are there. May be possible that these two value does not satisfy equation 3, or it satisfies equation 3. As it stands, let us see what we will get here. Either it satisfies or does not satisfy. So here lambda is equals to 1 and mu is equals to 1 satisfies or does not satisfy. Substitute lambda and mu is equal to 1 in this equation. So if you are substituting lambda is equal to 1, 1 into 10 is 10, and if you are substituting mu is equal to 1, so here we will get 1. 10 minus 1 is 9. So 9 is nothing but right hand side. Means here we can say that these values satisfies equation number 3. So if it satisfies, means after substituting these values in this equation, if you are substituting on this side lambda and here mu, both the sides are equal. So this is nothing but what? X coordinate of a point on the line first, and this is X coordinate of a point on what? Line second. So if X coordinate are equal, and definitely this value will satisfy which equation? 4 and 5. Means it satisfies these two equations. But because by solving equation 4th and 5, we have got these two values. Means definitely it will satisfy these two equations. Means it will satisfy these two equations. If it satisfies this equation, means y coordinate. This equation we have got by comparing y coordinate. Means y coordinate is also equal and z coordinate is also equal. Remaining part is to check whether x coordinates are equal or not. So that's why we are substituting this value in equation number 3, because equation number 3 we have got by comparing what? X coordinate, isn't it? Now if it satisfies, means x coordinate are also equal, these x coordinates are also equal, means we can say that these two line what intersect, means x coordinates are also equal, y coordinates are also equal, and z coordinates are also what equal. In case if it does not satisfy this remaining equation, then we can say that the two line what does not intersect. But as what will happen if it does not satisfy this equation, means this x coordinate and this x coordinate are what unequal. If x coordinate of these 2 points are unequal, means definitely these two lines does not intersect. Hope you have got it. Now since it satisfies equation number 3, hence we can say that hence both the given lines intersect. And if these two lines intersect, then to find out coordinate, now we have proved that the line intersects. Second part is to find out what coordinate of point of intersection. Now we have two choices: either substitute the value of lambda in equation number first and try to find out point of intersection, or substitute mu in the equation 2 and try to find out point of intersection. In both the cases you will get the same values. So we are substituting lambda is equal to 1 in equation number first. So put lambda is equal to 1 in equation first. So therefore coordinate of point of intersection is let us check what we will get here. So if we are replacing lambda is equal to 1, so minus 1 minus 10 will be equals to minus 11. So now again substitute lambda is equal to 1 here, minus 3 minus 1 will be equals to what? Minus 4. And lastly, if we are substituting lambda is equal to 1, 1 plus 4 will be equals to what? 5. In this way we have got the coordinate of point of intersection also. So here we have shown that the two lines are intersect, and later on question is to find out point of intersection. So we have got here coordinate of point of intersection also. Now let us try to solve the example number 10 here. In question number 10, a line passes through one point, means coordinate of one point on the line is given to us, and it is perpendicular to two lines. Find its equation. So here it is not given that find the equation either in vector form or in Cartesian form. That is our choice. But as it stand here, only one point is there. So we have to apply this formula: r bar is equal to a bar plus what? Lambda b bar. Applying this formula, we are able to find out equation of line. What is a bar here? Position vector of one point on the line. So coordinate of one point on the line is given to us. Using it, we are able to find out position vector of a point. So let us denote the position vector of that point by a bar. So let a bar be the position vector of point. So what are the coordinate of point? 3, minus 1, 2 on the line. From the coordinate of this point, we can say that value of a bar is equal to 3i cap minus j cap plus 2k cap. Well, once the value of a bar is known to us, now to find out value of b bar, we have to make the use of given another condition in the example. What is another condition? That our required line is perpendicular to these two lines. So now required line, since required line is perpendicular to the lines. What is the equation of first line here? R bar is equal to I cap plus j cap minus k cap plus lambda into equation of 2i minus 2j plus k. Equation of second line is, and R bar is equal to, what is the equation of second line? 2i cap plus j cap minus 3k cap plus mu into I cap minus 2j cap plus 2k cap. Now try to understand the given condition here. So let this will be say required line, and the given two lines are what? Perpendicular. So this line first and line second are perpendicular to our required line. Now already we have seen the equation of lines also. This equation is in the form of r bar is equal to a bar plus lambda b bar. This b bar is nothing but vector is, this B bar is nothing but what? Vector parallel to the line, or in other word we can say that it is vector along the line. So here let us denote the vector along the line first, will be say B bar. And vector along this line is what? This vector. Let us denote this vector by what? C bar. It is also in the form of R bar is equal to A bar plus mu B bar. This B bar is nothing but what? Vector along the line. So just simply we have denoted this vector by what? C bar. Since both the lines are perpendicular to required line, means these two vectors are also what? Perpendicular to required line. If we are taking cross product of these two vectors, we will get new vector. Which new vector? B bar cross C bar. Now B bar cross C bar is nothing but a new vector which is perpendicular to B bar also and perpendicular to what? C bar. But these B bar and C bar are perpendicular to required line. And this vector is also perpendicular to these two vector. Means we can say that this B bar cross C bar is what? Parallel to the line. And here B bar is nothing but what? Vector parallel to the line. But instead of B bar, here which vector is parallel to the line? B bar cross C bar. So instead of denoting it by B bar, let us denote it by what? B bar cross C bar. So because here we will require which vector which is parallel to the line, and according to given condition, which vector is parallel to the line? B bar cross C bar. Well, now here since these two lines are perpendicular to required line, so therefore vectors B bar is equals to 2i cap minus 2j cap plus k cap, and C bar is equals to what is the next vector along second line? I cap minus 2j cap plus 2k cap are also perpendicular to required line. That is, or therefore B bar cross C bar is a vector if B bar and C bar are perpendicular to the line. If B bar and C bar are perpendicular to the line, then B bar cross C bar is what? Parallel to the line. Therefore B bar cross C bar is a vector parallel to the line. Now we are finding cross product of these two vectors. So therefore B bar cross C bar is equal to, we know that cross product can be found out using what? Determinant. In the first row take the basic vector I, j, k. In the second row write down the coefficients from second vector, that is 2, minus 2, 1, and coefficient in third vector are 1, minus 2, 2. Let us simplify this determinant to find out our required value of B bar cross C bar. First write down I cap here, delete this column. This product is minus 4 minus minus plus 2, means minus 4 plus 2 will be equals to minus 2. Here plus j cap is there, so take minus j cap, delete this column. 4 minus 1 will be equals to 3. So here minus 3k cap, 3j cap. Lastly, let us try to find out coefficient of k cap. Delete this column. This product is minus 4 minus minus means plus 2. Minus 4 plus 2 will be equals to minus 2. So therefore equation of required line is R bar is equals to A bar plus here already lambda is used here, mu is also used here. So denote here scalar by any another notation. Let us denote it say by alpha B bar cross C bar, because A bar plus lambda B bar is our equation, but B bar is what? Vector parallel to the line. But as it stands, which is the vector parallel to the line? B bar cross C bar. So instead of B bar, here we are writing B bar cross C bar here, because here vector parallel to the line is B bar cross C bar. So therefore R bar is equal to, replace A bar by its value. What is the value of A bar here? 3i cap minus j cap plus 2k cap plus alpha into B bar cross C bar is nothing but minus 2i cap minus 3j cap minus 2k cap. Or this equation can be also written as 3i cap minus j cap plus 2k cap plus alpha into, now try to understand here. Now this is the vector along this line, required line, isn't it? And if vector along the line is given to us, at that time coefficients are nothing but coefficient of I cap, j cap, k cap are nothing but what? Direction ratio. So what direction ratios we are getting here? Minus 2, minus 3, minus 2. These are nothing but what? Direction ratios. If these are the ratios, means we are able to multiply to these three values by any number, or we are able to divide it by any number. But here if you observe, all the values are negative. If we are dividing to it by -1, we will get what? 2, 3, 2. Means these are nothing but what? Direction ratios. If these are the ratios, means we are able to cancel the common factor. If we are cancelling -1, -1, -1, so here we will get new direction ratios are what? 3, or these direction ratios can also be written as what? 2, 3, 2. If we are writing direction ratios in this form, at that time, from this direction ratio, what will the value of vector along the line? 2i cap plus 3j cap plus 2k cap. Means instead of minus, here we are able to replace this minus by what? Plus sign also. Means if you do not like that negative signs, so since in this case only, you are able to change the sign also, because this is the vector along the line. Then coefficient, if it is the vector along the line, means coefficients of I cap, j cap, k cap are what? Direction ratios. If they are the direction ratio, we are able to cancel the common factor. After cancelling -1, we will get 2, 3, 2. So this equation can also be written in this form also. So in this way, we have got required equation of line. So now observe the last example from this exercise, question number 11. Here equation of one line is given to us, and we have to show that this line passes through what? Origin. When we can say that this line passes through origin, if origin is the point on the line, if origin is what? Point on the line, at that time we can say that line passes through origin. And when we can say that origin is the point on the line, if the coordinate of origin satisfies equation of this line, at that time we can say that origin lies on this line, or in other word we can say that line passes through what? Origin. So already we know that coordinate of origin are what? 0, 0, 0. So coordinate of origin are 0, 0, 0. So now we are substituting x is equal to 0, y is equal to 0, and z is equal to 0 in equation number first. So put x is equal to 0, y is equal to 0, and z is equal to 0 in equation first. After substituting the values in this equation number first, here this first term, second term, and this third term are what? Equal. If these three values are equal, at that time we can say that coordinate of origin satisfies this equation, and if coordinate of origin satisfies this equation, means we can say that this line passes through what? Origin. So let us substitute these values in this equation. So what we will get here? 0 minus 2 upon 1 is equal to 0 minus 4 upon 2. Replace z also by 0, 0 plus 4 upon minus 2. So therefore minus 2 upon 1 is minus 2. Minus 4 upon 2 is minus 2, and 4 upon minus 2 is also what? Minus 2. All the values are equal. That's why we can say that therefore coordinate of origin satisfies equation first. And since this coordinate of origin satisfies this equation first, means equation of line, means we can say that line passes through origin. Hence we can say that hence given line passes through origin. Okay. In this way we have completed all the example from first exercise. In the next video we will start next article from this chapter.